Good morning. Today is a quick review on special right triangles. We will be going over the 45, 45, 90 triangles and 30, 60, 90 triangles. So to first look at the 45, 45, 90, this is a specific case. When one of the angles is 45, that means the other angle must also be 45, as all the angles must add up to 180 degrees. From here, we can look at specific situations in which we know that the legs are going to be the same and the hypotenuse will be slightly bigger, but at the same rate. So if we look at this example right here, we're saying that if one of the sides is x, the other side is x, meaning that you could plug in any number in. Let's say we plug in the number 5 here. If this number is 5 for this leg, then the other number is also 5. That means the other number, the hypotenuse, will be 5 root 2. In a second, we will go over how to calculate that. But that is just a very quick example. Looking over here at the 30, 60, 90 triangle, we have a short leg and a long leg. Now, those depend on the angle. So if the angle here is 30 degrees, the opposite side is the smallest side. Whereas here, we have a 60-degree angle, so this is going to be the middle number, or it's going to be the longer of the two legs. And then across from the 90-degree angle, this box here, will be the biggest side, so that's the hypotenuse. So based off of the angles, that kind of shows which side is going to be the biggest, the smallest. When we look at the example, or just the baseline model of it, across from the 30-degree angle will be the shortest side. So you can put SS if you'd like for short side. Let's just say in this example, this number would be 5. Then across from the bigger side, this is going to be the longer side. You can always use LS. That's going to be 5 root 3. Again, you can plug that into your calculator and see what it exactly is. But that would be your exact answer. What's kind of cool here is if you compare the short side to the hypotenuse, this is double. So in this case, it would be 10. So we're just going to look at two examples very quickly, but we're going to use trig to prove that this is the case. So in this example over here, we're going to assume that our answer should be something about 8 root 2. Let's use trig to solve this. In this problem, 8 would be our adjacent side based off that 45-degree angle. Our x would be the hypotenuse. So we are using cosine here. So to use cosine to solve this problem, cosine of 45 degrees is equal to the adjacent side, 8, over the hypotenuse, x. When you would solve that problem, again, one little quick trick is to swap these two. So it's going to be x is equal to cosine, x is equal to 8 over cosine of 45 degrees. Now, if we plug that in our calculator, 8 divided by cosine of 45 degrees, we get 11.3. If we plug in 8 times the square root of 2, we get 11.3. So they are the exact same numbers and kind of proves that that theory works. Let's look at one more example. If we look at our example right here, across from the 30-degree angle is our short side, so that's just going to be x. So this would be 2x. So we're going to assume that the answer here is 20. Now again, the same thing here. We're going to use sine. So sine of 30 degrees is equal to 10 over x. When we solve, we would plug in x is equal to 10 divided by sine of 30. And let's check that with our calculator. So when we plug that in, 10 divided by sine of 30 degrees, we do get 20. So again, that's just a quick way to find these numbers. We can use these strategies. And again, here is your kind of basic